Right, let's go through the homework then. So the question 1, you had to write it as a single fraction in its simplest form, just like you would with normal fractions. You need to make both denominators the same. And so we're going to make both denominators 15 because that's the lowest common multiple. So I'm going to multiply top and bottom by 3 of the first fraction, and then top and bottom by 5 of the second fraction. So for the first fraction, I get 3x plus 9, because I'm multiplying it all by 3, over 15. Plus multiplying the whole of the second fraction by 5, 5x minus 10 over 15. I can now put it over one common denominator, which is 15, and then I tidy up. So 3x plus 5x is 8x. I'm going to put 8x here. And then I've got 9 take away 10. So I've got to be careful. So 9 take away 10 is minus 1. And that's it. For the next one, everything is as normal, that you multiply the indices because you've got the brackets. And so you're going to do 9 times a third. And 9 times a third is, you can even do it on the calculator, but it's 3. So a to the power of 3. And then 6 times a third. So now I'm going to do 6 times a third, which is 2. And again, you can do it on the calculator if you can't remember how to multiply by fractions. The bit that a lot of people find tricky is that I've got to do 8 to the power of a third. Okay, I'm going to do this in a different colour over here. Right, 8 to the power of a third. We learnt that to the power of a third is the cube root of a number. So it's the cube root of 8, which is 2. And so that makes our final answer 2a to the power of 3, e to the power of 2. And you would have got 1 mark for getting the a to the power of 3 and e to the power of 2. But for the full 2 marks, you needed to get the 2 there. Okay. Right, we want to solve this. Again, like before, we want to make common denominators. So I'm going to make these both over 24y. And in order to do that, I'm going to multiply the first one top and bottom by 8. And the second one top and bottom by 3. So then I get 16 over 24y plus 9 over 24y equals 5. I put them together. 16 plus 9 is 25, so I get 25 over 24y equals 5. And now it's really simple. I'm going to multiply both sides by 24y. And I get that 25 equals 5 times 24. I'm going to try and do that quickly in my head. Brain shutting down. Is 120. So I've got 120y. And then I divide both sides by 120. So both sides by 120, and I get that, that I will have to use a calculator for. So let's see, 25 divided by 120. I'm going to leave it as a fraction because it gives me a recurring decimal. So I'm going to leave it as y equals 25 over 120, and then I'm just going to simplify. So 5 goes into both. Divided by 5. So 5 goes in, so 5 over 24. I'll just leave it like that. Okay, next we've got expand and simplify. You know, I love using the grid. You don't have to. Some of you use arrows. So m minus 8, m plus 5. Fill in the grid. M times m is m squared. Minus 8 times m is minus 8m. M times 5 is 5m. And minus 8 times 5 is minus 40. And we can put together our like terms, so these two. And our final answer then is m squared. 5 take away 8m, so 5m take away 8m is minus 3m and minus 40. And that's it. Okay, for factorising, we look at the biggest number that goes into both 5 and 20, and that is 5. So I'm going to take 5 outside the brackets. And there is a y that appears in both. I'm going to take 5y out of the brackets. How many 5s go into 5? 1. And obviously I've got the y already out of the brackets. How many 5s go into 20? 4. And I've got one of the y's outside the brackets. So what I've got left in the brackets is 1 plus 4y. Okay. Next one, anything to the power of 0, doesn't matter what it is. It could be a million, it could be 1,600,033,000 to the power of 0, and it will still always equal 1. So that one's nice and easy. Right, we need to solve this. The first thing I would do is expand the brackets. So 3 times 2x is 6x. Take away 3 times minus 5 is minus 15 equals 9 minus x over 2. Then I would multiply both sides by 2 to get rid of the divide by 2 here. And I end up with 12x minus 30 equals 9 minus x. Then I think I'm going to put all the x's onto this side. So I'm going to plus x on both sides to get rid of the minus x here. And I get 13x minus 30 equals 9. Then add 30 to both sides to get rid of minus 30. And I get 13x equals 39. And then divide both sides by 13 to give me x equals 3. And that's it. And that's 4 marks, and so it's worth being able to start these questions. Simplify all of these. We've done these before. So we've done these before. A times A times A times A is just A to the power of 4. 5a times 6b. 5 times 6 is 30. And then you've got a times b, so ab. Here, remember when we're dividing, we subtract the indices. So 8 take away 2 is 6, so q to the power 6. Right, next one, I ask you to solve 5 minus 2y equals 12. So we are going to take away 5 from both sides to get rid of the 5 here. And what we're left with on this side is minus 2y equals 12 take away 5 is 7. And then we're going to divide both sides by minus 2 to give y equals minus 7 over 2. If you wrote minus 3.5, that's also fine. Either way, you would get the full 2 marks. I told you to leave C, so you shouldn't have done it. Next one. So remember, when they're next to each other like this, we're going to multiply. So 15 times 2/3. So 1/3 is 5, and then 2/3 must be 10. So we get e to the power of 10. So that's a nice easy part. The hard part is doing 8 to the power of 2/3. And again, I'll do this in a different colour at the side. 8 to the power of 2/3. And again, we did this in class. We can separate it into 8 to the power of a third, all squared. Okay, so I can separate the 2 and the thirds out. We already said earlier on that 8 to the power of a third is the same as cube rooting 8. And then we square it. The cube root of 8 is 2. And 2 squared is 4. And so our final answer here is 4e to the power of 10. Next, we want to express this in this form here, where a and n are integers. Integers just means whole numbers. Okay, so again, we're using our knowledge of negative indices. We said that if it's negative, we flip it, and the indices becomes positive. So we're going to write 2 over y to the power of 4. Actually, it's simpler than that. I've just realised it's simpler than that. So it's 2 over y to the power of 4. So it's nice and simple. And so that's also the same as writing 2y to the power of minus 4. Okay, because the y to the power of 4 means that it would have been underneath, because this is the same as saying 2 times y to the power of 4. Okay, so we've just written that now in the form that they wanted. Next one. We want to solve this. Again, let's make the common denominators. We're going to make both denominators 12. So I'm going to multiply the first one by 4 and the second one by 3. And so then let's do this. And because I'm changing both, then that's okay. It's still the same fraction. We're just putting it over all over one denominator. Okay, so here I get 16x minus 8 over 12. Take away 15 minus 9x over 12 equals 6. Then I'll tidy up, and I'm going to do 16x. I've got to be careful, take away minus 9x. So that's plus 9x, so it's 25x. So 25x. And then I'm going to do minus 8, take away 15, which is minus 23, all over 12 equals 6. Multiply both sides by 12, which if you did the other method, that's exactly what you would do. Because I know in class we've done it the other way as well, where I've multiplied everything by 3 and then everything by 4. And that includes the number on the other side. Okay, this is just the same thing. So then I get 25x minus 23 equals 72. I add 23 to both sides. So 72 plus 23 is 95. And then I do 95 divided by 25, which gives me 3.8. X is 3.8 for that one. Okay, right. The clue I gave you for number 5 was to factorize the quadratics. Now, what worries me is that some of you are still struggling with factorizing these quadratics. It is worth spending time learning this and really committing it to memory, because this doesn't just come up as a separate question. It comes up in other questions as well, where you have to factorize quadratics like this. So you should learn it. So here, I can see that, sorry, I just realised there's a cubic on the top, so I'm going to have to take the x out. So I'm going to take an x out of here, so it becomes 2, here it becomes 1, and then out of here. So I'm going to take it out, and it becomes 6x plus 13x, sorry, no, 6x squared, plus 13x minus 5. Okay. Then I just need to factorize this bit, which is what we learned in class. We multiply these two, so 6 times minus 5 is minus 30. I'm looking for two numbers that multiply to make minus 30, but add to make positive 13. So that's going to be minus 10 and minus 3. No, it's not. No, it's not. Let me think again. It is not. So there we go. We'll make mistakes. It is not, because that doesn't, that adds to make minus 13. So to make positive 13, it's going to be minus 15. Minus 15, no, positive 15. Positive 15 and minus 2. And that adds to make 13, but multiplies to make minus 30. So then we do 6x squared plus 15x minus 2x minus 5. Squiggly line down the middle. Factorize this side. 3 is the biggest number that I can take out of 6 and 15. X comes out as well. And so here I've got 2x plus 5 minus 1 is the biggest number that goes into both 2 and 5. And then 2x plus 5 here, because minus 1 times 5 will give me back the minus 5. And then remember, we put together the bits outside. So 3x minus 1 and the 2x plus 5. Okay. So now going back to the original question, that top bit is factorized as x, 3x minus 1, and 2x plus 5. Oops, 2x plus 5. Now the bottom, you should recognize as the difference of two squares. If you don't, again, go back and revise it. So they're both square numbers, 4 and 25. So I can split them up. 2x here, 2x here. One is plus 5, the other is minus 5. Okay? Then it's nice and easy. You cancel any common factors. So 2x plus 5 and 2x plus 5. Because it's on the top and it's on the bottom, they cancel each other out. So then all that's left as your final answer is x times 3x minus 1 over 2x minus 5. And that's all you can do. You can't simplify it any more than that. Okay, going on to this bit. So this one was a bit challenging. It says find the value of x. So let's write these all Let's write this all in using 3 to the power something. So 3 to the power of x, and then we can write 9 as 3 squared, and then, so 9 is 3 squared, and then you've got to the power of 3x equals, and then 81 is 3 to the power of 4. Let me just work out. Yeah, 3 times 3 is 9. 9 times 3 is 27. 27 times 3 is 81. So that's 3 to the power of 4. Okay. Then I know that, okay, we've got 3 to the power of x. And then I can multiply these two indices, 2 and 3x. So that becomes 3 to the power of 6x equals 3 to the power of 4. Then I know that when I'm dividing, I subtract indices. So here, so when I'm dividing, I subtract indices. And so I'm going to do x take away 6x. So I am saying that x take away 6x is minus 5x. I'm saying that minus 5x, 3 to the power of minus 5x equals 3 to the power of 4. Because the base is the same, it means that these must be the same thing. So minus 5x must be equal to 4. So then I have to just divide both sides by minus 5. And so x must be minus 4 over 5. Or if you wrote minus 0.8, that is fine as well. Okay. Right, solve. When we've got a situation like this, although there are lots of methods you can use, the easiest way is to cross multiply. So cross multiply. Yeah. So 2 times 6x plus 1 is 12x plus 2 equals 3 times 5x minus 2 is 15x minus 6. And then we should all be able to solve something like that. I'm going to take the x's onto one side. So I'm going to minus 15x from both sides to leave minus 3x plus 2 equals minus 6. Then I'm going to minus 2 from both sides to give that minus 3x equals minus 8. Just making sure that I've done this right. I am doing this very quickly, so I apologise if I make any mistakes. Then I divide both sides by minus 3 to get x equals 8 over 3. I've got a negative divided by a negative, so the whole thing becomes positive. Solve this equation now. So this one is not as simple as cross multiplying. You can't do that. I need to make the denominators the same for this one. So the only common denominator is to multiply this one by x plus 1 and this one by x plus 1. This one by x minus 2 and this one by x minus 2. So what I get on top, so that should be plus 1, is 6x plus 6 over x minus 2 times x plus 1. Take away 6x minus 12 over, again, x minus 2 times x plus 1 equals 1. Okay, I tidy up the top. So I've got 6x, take away 6x, gone. That's 0. And then I've got to be careful. I've got here 6, take away minus 12. So 6 take away minus 12 makes a plus. So it's actually 18. So what I end up with is 18 over x minus 2, x plus 1 equals 1. And then, hold on, I'm just going to check it still. Yeah. Then I'm going to multiply both sides by the denominator. So I'm going to multiply both sides by this denominator here, so that it gets rid of it here, and so then I get 18, so I'm squeezing it in, 18 equals 1 times x minus 2, x plus 1. Okay, so I'm timesing it. Still not finished. Obviously, you can see this is a 5-mark question, so it's a lot of marks. We're going to multiply that out. You can use the grid. So x minus 2, x plus 1. So x squared minus 2x, x minus 2 put together are like terms. And what we get is 18 equals x squared. X minus 2x is minus x minus 2. Then I'm going to put it all onto one side so that I get x squared minus x minus 20 equals 0. I can then factorize this. And this is the nice factorizing. So two numbers that multiply to make minus 20, but add to make minus 1. And that would be 5 minus 5 and positive 4. Or other way round. Yeah, minus 5 and positive 4. And so my solutions are x equals 5 or x equals minus 4. So 5 marks, but at least if you can start it, that'd be great. Okay, here a lot of you struggled with this. It says that the playground is extended by adding 10 meters to its width. And so here we are adding 10 more meters onto the width and 20 meters to its length. Okay, so now that carries on a bit more, so 20 more here. Okay, so what we have now is we have a width that is x plus 10 and a length that is 3x plus 20. Then we are going to, it says to form the area of the larger rectangular playground is double the area of the original. Okay, so let's find the area of the original. So the area of the original is just 3x times x. So 3x times x is 3x squared. And then the area of the new would be x plus 10 times 3x plus 20. Now it's saying that the larger one is double times 2 of this. All right, so now that is saying that they are equal, and so that's 6x squared equals, let's multiply this out. I'm going to use my grid again. Just means that I can do it. Make sure I don't miss out any terms. So that becomes 3x squared, 30x, 20x, and 200 here. I gather my like terms here. So on this side, I've got 3x squared, 20x plus 30x is 50x. Oops, sorry. 50x plus 200. Okay, if you notice here, they've got it equal to 0. So they've put it all on one side. So I'm going to bring everything over to this side. So I'm going to take away 3x squared. So 6x squared take away 3x squared is just 3x squared. The plus 50x comes over and it becomes minus 50x. And the plus 200 comes over and it becomes minus 200 equals 0. And that's all you had to do for that one. And then it says calculate the area of the original playground. So we have to find out what x is by solving this quadratic. Admittedly, I haven't checked whether this can be factorised. Hopefully it can be. If not, you will have to use, then I perhaps shouldn't have set this as homework because we haven't yet gone over the quadratic formula. So I'm going to try and factorise, and if it doesn't, we will have to leave that one. So 3 times minus 200 is minus 600. And I'm looking for two numbers that multiply to make minus 600, but add to make minus 50. Ooh, so that would be, 20 and 30. But I've got to be careful with my... Got to be careful. No, that doesn't, because they can't both be negative. So I'm going to try something else. Minus 60 and 10. Yeah, minus 60 and 10. Because that will make minus 600, but add to make minus 50. Okay, that's nice and easy. So I'm going to do it here. So 3x squared minus 60x minus 10x and then minus 200 equals 0. Squiggly line. The 3x comes out because 3 is the biggest number that goes into 3 and 60. Here, x minus 20. Take away, I can take 10 out. And then here, x minus, not minus 20. Yeah, minus 20. No, something's gone wrong there. Let me have a look again. Oh, because that should have been positive. That should have been positive 10x, so plus. And then x minus 20 here. Then our brackets are 3x plus 10. And x minus 20 equals 0. So our solutions are x equals 10 minus 10 over 3, or x equals 20. Now, we know that this is impossible, so it cannot be a negative number because we've got a real life scenario here. Normally, if we were just asked to solve it, both solutions are valid, but because we're talking about an area here, no length can be negative. So that we count that out. X can only be 20. And it asks for the original area of the playground. So it would be 20 times 3x. So 3 times 20. Ooh. 3 times 20. And so we multiply all of that together. So 3 times 20 is 60. And so we get 60 times 20. 60 times 20 is 1,200 meters squared. Is your final answer. Not easy. Okay. Factorize this. Again, it's a difference of two squares. This is a square number. This is a square number. So 2x goes in one, 2x in the other. And then the square root of 1 is 1. So 1 is plus 1 and the other is minus 1. So that one's done. Next, we're going to do some solving. And so we want to make these a common. Now, notice how this was part A and this was part B. So they are connected. So I can make both denominators this. So the 4x minus 1 by only multiplying this one by 2x minus 1. Top and bottom minus 1. So then I get 8x minus 4 over 4x squared minus 1 plus 1 over 4x squared minus 1 equals 3. Put them together and tidy it up. So I'm going to do minus 4 plus 1. And that gives me minus 3. So I get 8x minus 3 all over 4x squared minus 1 equals 3. Multiply both sides by 4x minus 1, so I get rid of it there. And so I get, so I'll do it up here, 8x minus 3 equals 12x squared minus 3. Oh gosh, another quadratic to solve. Well, you know what? If you did this homework well, you definitely practice a lot of solving quadratics. So that's a good thing. And so I'm going to put them all onto this side to keep the positive x squared. So it becomes 12x squared minus 8x. I move the minus 3 over onto this side, so it becomes plus 3. And then moving it onto that side to make plus 3. Oh, it's gone. So it equals 0. Oh, it's not too bad then. So then I can take 4x outside the brackets. And inside the brackets, it's 3x minus 2 equals 0. And so our two solutions are x equals 0 or x equals 2/3. Okay. And if you're not sure how we got that, then remember to ask me. Then I asked you to expand this. So let's first of all do, I'm just going to use a space down here. Let's first of all do 2x minus 1 times x plus 3. Fill it in. I get 6x, oh, don't know why I said that. 2x squared minus x, 6x, and minus 3. And then I can put together my like terms, and that comes out as 2x squared plus 5x minus 3. Then I'm going to multiply it by the last one. So let me get my grid ready. I'm going to do 2x squared plus 5x minus 3 multiplied by x minus 5. Let's fill that in. So 2x cubed, 5x squared, minus 3x, minus 10x squared, minus 25x, positive 15 because they're both negative. Okay, let's put together like terms. So I'm going to put these together and I'm going to put these two together. So that my final answer is 2x cubed. Minus 10 plus 5 is minus 5x squared. Then minus 25 minus 3x, so it is minus 28x plus 15. And that's it. Did I get you to do any more? No, that's it.